Hey math kids, today we're going to talk about interval notation, and we are in your book in section 2E, and we're going to start with example 3. So we're given a set, but it's written in this new interval notation. And it asks us to describe what's going on. Now this is a z, so this is our integers. So essentially it's just asking us to write this in set notation, like the standard. And so what this says, x is contained on z, or the integers, which just means x is an integer. And then we just want to write down all the integers that are in between right here. Now since this is just less than, not less than or equal to, we don't actually get to 3, we get really close to 3. So the first integer that happens in this is just a 4. And then we do everything in between 4 and 10. And we actually write down 10 because there's an equal to line right there. So this essentially, they want us to write like in words how to say this. I'm going to let you just read your book. I'll read it out loud, but I'm not going to write it on the screen. So it says, the set of all x such that x, here I'll even point. So it's the set of all x such that x is an integer between 3 and 10, including 10, because of the equal to sign. Okay. So A, look in your book if you want to, read that. This would be answering part B. Then we're going to move on to C, which is n of A. And remember from previous lessons, n of A just says how many elements are in this set. So we just count 1, 2, 3, 4, 5, 6, 7. And that's our answer on that. Now we're going to move on to example 4. And this time we're given u, where x is an integer. We're given a, and we're given b. Okay, and then we want to list the elements of each thing that they ask for. So list the elements of A. Once again, it's on the integers, and these are both equal to. So A is going to be 1, 2, 3, and 4. And then they want us to do B. Once again, it's integers. We're equal to on the -3. 1, but we're not going to write 2 because we're not equal to right there. And then a complement. So it's everything that's not A. And remember, U is like the universal, so that's like everything that exists. And so everything that exists, I'm just going to write that. It's not asking us for this right now, but it might be helpful to see this. So that's what U would be written out. Now, complement of A. So A is everything except for 1, 2, 3, 4. So we're just going to start listing the elements of U until we get to the elements of A. Now, I would write 1, 2, 3, 4, but they're in A, so we don't want those. But then we got to include 5 as well. Okay, we also need to do complement of B. Similar process, we're going to write everything that's not in B. So we start at -5, -4, -3, 2, -1, 0, 1. Then we go 2, 3, 4, 5. Okay. And what's the next one? A intersect B. Let's see, we'll get blue. Okay, so A intersect B. So it's whatever A and B have in common. So I think we can move past this now. Okay, so whatever A and B have in common. So 1, 2, no. 3, no. 4, no. So it's just the set containing 1 on that one. And then we want to do A union B. So we want to write everything that's in A. 1, 2, 3, 4. And then everything that's in B that we haven't already written down. So -3, -2, -1, 0. We don't write the 1 twice when we're doing the union. Now A complement intersect B. So if we come to A complement and B, we just write what they have in common. They both have -3, -2, -1, and 0. And then the last one is A complement union B complement. And let's see, so it's here and here. So they both have it's union. So we write everything in A complement. And then anything that we didn't write. So we already got -5, already got -4. We need 2, 3, and 4 in there. So 2, 3, and 4. So this is all one set right here. Okay, that finishes that problem. And I think I'm going to have to split this into 2 videos. So look at part 2 for example 5 and calculator.